Hello. In this short video, I am going to show you a method that we can use to calculate average values of extensive thermodynamic variables in statistical mechanics. Before we get on to that though, let's just remind ourselves of some of the results that we have derived in previous videos. We have shown that if we minimize the information functionals subject to some constraints, the probability of being in any given microstate J is given by the expression shown here. Furthermore, in deriving this result, we have introduced the generalized partition function z, which is calculated as follows. We have also said that z is equal to e to the capital psi and have thus defined capital psi as the following logarithm. Let's now turn to the subject of this video. What we are going to do here is differentiate capital Psi with respect to lambda k. At first sight, this looks like a horrendous problem, but really it is not. All we are required to do is exploit the chain rule. In our first step, we thus differentiate the logarithm part, and the chain rule tells us that the derivative of the logarithm of a function is equal to 1 over the function multiplied by the derivative of the function. In this case, the function inside our logarithm is just e to the psi, so we have simplified the denominator here to e to the psi. Our next step is to exploit the distributive property of the derivative operator and to thus bring the differential operator, the partial by partial lambda k, inside the summation. We then once again exploit the chain rule in taking the derivative of the exponential as shown here. We now bring the 1 over e to the psi into the sum. And notice that the quotient shown inside the summation here is just the probability of being in microstate J. We thus arrive at the following summation, which we recognize as just minus the average value of the extensive variable b superscript k. In short, we thus arrive at the following result. The partial derivative of the logarithm of the generalized partition function with respect to lambda k is equal to minus the average value of b superscript k. The proof of this result is pretty straightforward. But if you cannot understand it, please try to work through the differentiation carefully in order to convince yourself. Thank you for your attention.